Hi, everyone. So my talk today is called Not Your Average Rate Limiting. My name is Pooja Mistry. I work at Postman, and Postman is a tool that is used by over 35 million developers worldwide for all things APIs, and GraphQL is a big one of them. So just to kind of give you a little bit of an insight on the GraphQL client, this is what the GraphQL client, it's recently been updated in 2023, and it's a new way for you to work with GraphQL queries, using introspection and test your APIs. But today's talk is all about rate limiting. So let's talk about rate limiting. If you were not familiar with the term before, with the recent announcements with Twitter and Reddit, you might be familiar with what API rate limiting is. But the way I like to think about it is that servers have limited resources, and all of the APIs users compete for them. This is sometimes what it looks like when you have a spot in the cab and somebody takes it. It's sort of unfair, and rate limiting helps by restricting the number of requests that a client can make within a particular set time frame. And so this ensures that fair usage of the APIs and prevents other clients from experiencing poor performance. So this is a really great quote from the Shopify blog that is used to highlight how rate limits are maintained for platform stability. Just shows how important rate limiting is. But there are definitely different challenges when it comes to GraphQL APIs. So over the past couple of days, we've learned that GraphQL puts the control in the hands of the client. It allows users to request exactly what they need when they need it. However, this flexibility can present some unique levels of challenge. So in this case, we're trying to request for specific reviewers. So while this flexibility helps clients retrieve only the information that they require, it also complicates rate limiting. And so, for example, resolving one query might result into calling multiple APIs in the back-end rating services. And so these queries can be nested, and they consume various different resources. So basically, rate limiting has to account for some of this complexity and assign limits based on the impact of each query. So when we think about optimizing for GraphQL, the number of requests alone isn't really a good representation for the loads on the server, since it doesn't really take into consideration the nature of these requests. These can significantly vary. So to address this, we need to measure the complexity of each request. And so there's a concept called the query cost analysis, and the query cost analysis assigns a weight or a cost to each of these requests based on key factors. So the first factor is type complexity, and the second factor is resolve complexity. So type complexity reflects in the size of the data being retrieved, whereas all types are not equal, whereas resolve complexity considers execution costs, including network and data retrieval. So understanding these types of complexity involves minimizing some different accidental services. So this is a graph that shows a linear correlation between query complexity and execution time, which basically results in various different effectiveness. So let's think about the query cost analysis techniques. So there are three techniques I like to think about specifically. So the first technique is the static query analysis, so which prevents servers from executing queries that are deemed too risky. So these are performed before a query is executed, and it's predicted. The cost is predicted by an upper bound estimate. So since these are performed before the query is executed, they can be a little bit more risky, whereas dynamic cost analysis is performed within the execution engine, making it more precise, which is its key advantage. However, the downsides include modifying the execution engine, and you have to wait until the execution is underway for performing actions like read and writes to backend data. So it's hard to kind of know the exact cost of the actual cost of this type of analysis. And then there's the response cost analysis. So once the response has been executed, resources cannot be saved, but analyzing these responses allow you to account for different costs in the future. And this approach provides more accurate cost estimation, but your team doesn't really have a direct control over the GraphQL servers. So while there are different query cost analysis are different, there are different things to consider, such as for implementation. So for example, introspection queries, they are sometimes overlooked, but they consume a lot of resources and they should be accounted for. Pagination, requesting hundreds of repositories differs in cost from requesting 5. So the actual query cost might differ from the expected cost. For example, if only 5 entries are returned, the client should be credited accordingly. And then there's always complexity calculation overheard. So let's look at some examples. So Shopify, for example, Shopify assigns points based on GraphQL types. So mutations are the most expensive type of queries since mutations involve number of write operation. So a lot of this is done in the static analysis, so before these queries are particularly sent. Whereas GitHub uses static analysis to calculate the total number of nodes in a query, but it uses dynamic analysis to perform the execution within the engine to determine the overall cost. And whereas Yelp uses the response cost analysis that we've discussed, the response limits are basically determined by the amount of data that is returned, and so different types can, such as reviewers, locations, those are assigned by different weights. And querying a business, for example, these weights aren't necessarily based on the number of fields queried, but rather than the particular type that is resolved. And so ultimately, there's not really a right answer. Everyone kind of does things differently, so that's, there's different ways. But to think about what the cost analysis of your weight in rate limiting is a good way to think about how you can use a combination of various different strategies to build the right rate limiting techniques. And so the road ahead. So for example, compilers, these can enhance performance and improve security through rate limiting, and they simplify API maintenance. So example, Apollo's compiler, I believe, is written in Rust that can include some sort of recursion limits. And then you can also take a potential machine learning approach, which allows you to work with higher accuracy to understand different traffic patterns and optimize for certain rate limits. So with that said, I wanted to share a concept cards QR link. And this is a link that is built by our Postman team in general. So if you're interested in just learning about some of these concepts, such as rate limiting, static versus dynamic versus response type of approaches, you can take a look at this QR code. And so these are some of the additional resources that I have put into place. I'm going to post this if anyone wants to take a picture of that, just to kind of get some more insight into resources. And with that, I believe that is the end of my talk. So thank you so much. Hope everyone has a great day.